Example 3 says, consider the graph of the function f of x below. Use the graph to answer the following questions. Evaluate f of negative 2. All that means is that if this were like the vending machine example, if you punched in the code -2, what snack would pop out? And so let's try to highlight that on our graph. So we have our input value of -2 right here. I'm going to see and go up here, and you can see that the associated output value is this value right here, which is 4. So we're going to say that f of -2 is equal to 4. Okay, the next question asks us to evaluate f of +2. And so here's our 2 value. Now it kind of seems like if we go up here, our answer would be +2, but notice that that's an open circle or open dot. And so really our output value is the one right here. And so the associated output value is 3. So f of 2 equals 3. All right. So part C says, for what values of x does f of x equal 1? And there could be multiple answers for this, but this is like the equivalent of saying, like, what code do I have to push on my vending machine so that I get the snack 1? Notice here that our snack 1 is right here, and if I kind of highlight outwards, there are 2 places where I could have an input that gives me an output of 1. So one of them is happening right here, and another one right here. So this one has 2 answers. We could say x equals 1 or x equals -1. And another way of writing that is we could say f of 1 is equal to 1, and then f of -1 is equal to 1. So either of those ways that you write is acceptable. So those are the answers for part C. Part D says, on what intervals is f of x increasing? Just like when you're reading a book, in math, when you're reading a graph, we read from left to right. And so it's probably pretty intuitive. A graph is increasing if we read from left to right and it's going upwards. So let me highlight on the graph the areas where the graph is increasing or going up. So it's happening on these locations. Now, whenever we're talking about increasing or decreasing on an interval, we always use the x values, and generally we use interval notation or inequality notation, but I'm going to use interval notation, and I'm going to put parentheses on all of the endpoints because it's not exactly increasing exactly at that point, but that may differ depending on who you talk to or like a textbook that you're looking at. But for the purposes of this class, I'm just going to use parentheses. So we can say f of x is increasing on the intervals 0 to 1 and 2 to 4. All right. Now, part E says, on what intervals is f of x decreasing? So let me highlight those on the x-axis. So because there's an arrow right here, that means it goes on. Oh, I made a mistake. There's an arrow there too. So actually, it doesn't just stop at 4. This goes to infinity. Hopefully you caught that before I did. Okay, so let's go back, and I want to highlight the places where it's decreasing. So because we have that arrow there, that means that the graph is like decreasing all the way up to 0 from the very left side. It's not increasing or decreasing between 1 and 2, and then everywhere else it's increasing. So basically it's decreasing everywhere before 0. So we can write this in a couple ways. We can say f of x is decreasing on the interval -infinity to 0. or we could say, or when x is less than 0, like that. So either of those is fine. Part F says find the minimum and maximum values of f of x. So the minimum value is going to be the lowest point on the graph, and the maximum value is going to be the highest point. Notice that there is no maximum because, again, these arrows are here, so they're going to go up forever and ever, and so we can't really attain a maximum point, although there is a minimum point, and it's happening right there at the origin. So let's think about how we're going to write that. We can say there is no maximum, and then we could say there is a minimum value of 0 when x equals 0. Okay, part G says for what values of x is f of x positive and for what values of x is f of x negative. So notice that our graph does not go below the x-axis, meaning there's like no graph portion down here. So really our graph is never negative. And then when is it positive? Well, it's positive almost everywhere. Remember that 0 is neither positive or negative, so it's basically positive everywhere except when x equals 0. So let's answer this. So we can say f of x is never negative. And then we could say f of x is positive on the interval negative infinity to 0. We don't want to include 0. I'm going to write this like capital U looking symbol, and that symbol is the union symbol. And basically, just like in a marriage, when you're combining two families together, a union in math is when you're combining two intervals together or two sets. So I'm going to combine those two intervals, and all that interval is basically saying it's like all the numbers except 0. Okay?